In this video, we're going to study how to do angle proofs with two-column proofs. In the previous chapter, we have done properties of equality and properties of congruence. And if you recall correctly, that property of equality was mostly applied to algebraic proofs. And so it includes four additions: distributive property, substitution property. And then these three properties, reflexive, symmetric, and transitive property, can be applied to both properties of equality as well as congruence. And again, the difference is that when it comes to equality, we're talking about mostly quantities, numbers, measurements, things that can be represented by numbers and variables. And congruence, we're talking about shapes, sizes, as well as measurements. So that's the difference here, okay? And today we're going to learn more about what else we can do, what else we can use for angle proofs. Also, I want to note that arguably this chunk, all three units, 2.678, are the most challenging with two-column proofs. So you do have to pay close attention to details. And when you solve problems and provide the proofs, you have to provide step-by-step solutions as well as the reasons behind them. So, okay, let's take a look here. Here we have some definitions. Definition of congruence simply says that if the measure of angle A is the same as the measure of angle B, then the two angles are congruent. I want you to pay attention to this two-way arrow. This means that it's biconditional, right? I'm trying to get my pen here. So let me do this. So I want you to pay attention to that. And by biconditional, it means that if and only if. Biconditional. It also means that both the inverse and the converse are true. So if angle A the measure of angle A is 60 degrees and angle B also measures 60 degrees, then I can draw the conclusion that these two angles are congruent. But if I know angle A and angle B are congruent, then I can draw the conclusion that they are both of the same measure. In this case, is 60 degrees, right? So second definition is an angle bisector. An angle bisector, any kind of bisector simply divides anything into two equal parts. And in this case, it's an angle bisector, so it's dividing an angle by two equal parts. And if we draw an example, it will be something like this. So we can say angle 1 and angle 2 are congruent, and therefore this dark blue ray in the middle is an angle bisector. Definition of complementary angles, and again, this is a two-way arrow. It's a if and only if. It's biconditional. If two angles are complementary to each other, then their sum is 90 degrees. And definition of supplementary angle is if two angles are supplementary, they add up to 180 degrees. And definition of perpendicular simply says that perpendicular lines like this form a right angle right here. So again, that's definition of perpendicular. And definition of right angle is if I have a right angle, that angle must be 90 degrees. So these are definitions. And below we have some postulates. Remember, postulates are just commonly recognized statements. So they're simply statements that everybody accepts them as facts. So angle addition postulate, in this case, just simply says that if I have one angle right here, ABD, and then if I add the second angle here, the angle measurement DBC, then I would have one big angle ABC. So that's angle addition postulate. Also, just a reminder that remember this, we also had segment addition postulate, right? So it's the same thing. That was adding two segments together, and now we're simply adding two angles together, same mechanics. Below we have some theorems. In this part, I really want you to pay close attention here. First, vertical angle theorems. It says that if two angles are vertical, then they must be congruent. So if I have angle 1 and angle 2, right? If I know that they are vertical angles like this, looking like scissors, then I can draw the conclusion that angle 1 and angle 2 are congruent. Complement theorem. If two angles form a right angle, then they are complementary. And here I want you to pay close attention. That complementary theorem says if I already have two angles that form a right angle, then they're complementary to each other. So this is a one-way street. If you pay attention here, this arrow here is one way. So the hypothesis has to have right angle in there, okay? Same thing with supplemental theorem, that in this case, it is if two angles form a linear pair, then they must be supplementary. So if I switch the hypothesis and the conclusion, it wouldn't work. So that's supplement theory. Congruent complements theorem. If angle A is complementary to B and C, to angle B, and angle C is complementary to angle B, then angle A and angle C are congruent. So this is very much like the transitive property, right? Same thing with congruent supplements theorem. If angle A is supplementary to angle B and C, angle B and angle C is supplementary to angle B, then angle A and angle C are congruent, and that's congruent supplements theorem. So now let's look at how we can use some of these. Here we're asked to justify each of the following statements using a definition or a theorem or a postulate. You all have a sheet that has a guideline that includes all the properties. I call it a property bank. So you're welcome to use it, but really what I encourage you to do is, rather than memorizing those things, truly understand what the definition means in terms of if you can draw a picture about it, and how is the definition different from another definition that may have similar keywords in it, or that may describe the same kind of angles or segments. And that way you don't need to memorize the thing, it's all in your head. So number one, if angle A is a right angle, then the measure of angle A is 90 degrees. This, if you look back, is the definition of right angle. Number two, if angle X is supplementary to Y, angle Y, and angle X is supplementary to angle Z, then angle X and angle Z, actually, I think there's a mistake here. X is angle Y and angle Z. Yep, that's right. Angle Y and angle Z should be congruent. That's right. So this is very much like the transitive property, right? And it has the keyword supplement here. So this is congruent supplement theorem. And the congruency is here, right? Number three, look at this graph. If angle 1 and angle 2 are vertical angles, then they are congruent. Obviously, this is vertical angle theorem. I'm abbreviating there. Number four, if angle P and Q adds up to 90 degrees, then they are complementary. This is definition of complementary angles. Some of you may say, why is this not complement theorem? If you look at that definition of complement theorem, it says that if two angles form a right angle, and right here, there's no word that specifically says right angle. It actually specifically refers to the angle measure, the sum of the angle measure. Those are two different things. So just be aware of that difference. Again, complement theorem, you have to have a right angle already that's formed by two angles. I need to see those words in English, right angles, okay? And look at number 5. Surprise, surprise. If angle M and angle N form a right angle, then these two angles are complementary, and this is my complementary theorem. Complement theorem. I misspoke. There we go. And number 6, given line M and line L are perpendicular to each other, then angle 1 is a right angle, and this one was definition of perpendicular, I think, right? There's no other things to say it. I just use that symbol to represent perpendicular. Let's look at number 7. If angle W and X are supplementary, then they must add up to 180 degrees. And this is definition of supplementary angles. Number 8. If angle L is complementary to M and M is complementary to M, then angle L and angle N are congruent. And this is very much like transitive property. So we said that this was congruent complement theorem. Congruent, I think it's, yeah, complement. Number 9, if A and B form a linear pair, then they must be supplementary. So this is supplement theorem, right? Number 10, if angle N and P are complementary, then they add up to 90 degrees. This is definition of complementary angles. Number 11, given this graph here, angle measure JKM, which is right here, plus angle measure MKL, which is here. If I add them up, I would have the whole big angle. So this is angle addition postulate. And number 12, if the angle measure for R and S are the same, then these angles are congruent. And that's simply definition of congruence. Okay, so I'm going to try to do a couple of examples and help you out. This part, if you have any questions, please make sure that you see your teachers either before the classes begin every day or after school or during break tutorials, because it is really hard, and it's one of those things that you think you know, but when it's applied, you get stuck. But then when you see how other people demonstrate their reasonings, it makes perfect sense. And all of that, trust me, comes with practices. So here, angle proofs. We're to complete the proofs below by giving the missing statements and reasons. Number 1, we know that PQR is a right angle. Tip, whatever it's information you get, if you can label it on the graph, it really helps you think. We have to prove that PQS and SQR, PQS is here, SQR is here, they are complementary. And in order to prove that, we have to prove that they add up to 90 degrees. So let's see how we do that. The first one, even if I close my eyes, I know the first one is always given. PQR is a right angle, therefore the measure of PQR is 90 degrees. I can draw that conclusion by definition of right angles. And I also know the measure of PQS and the sum of PQS and the SQR adds up to PQR, and that's just a visual observation right here, right? So I do that because of angle addition postulate. I add the two angles together. And now what I can do, if you look at step 2 to step 4, what I can do is that because I have this here, right, these two are the same thing. So I'm simply doing a transitive property, or you can do a substitution. Either one works. And therefore, now that I know these two angles adds up to 90 degrees, I therefore can draw the conclusion that they're complementary, and that's because of the definition of complementary angles. Okay? Number 2, given angle 2 and angle 3 are congruent. So angle 2 and angle 3 are congruent. Angle 1 and 2 form a linear pair, that I can see. So we're to prove that angle 1 and 3 are supplementary. So let's write down the first one is always given, but I also like to look for what else is given and look down. In this case, step 3 is also given right here. Okay, so now I go back. Step 1, I know the two angles are congruent, therefore I can draw the conclusion that their angle measures are the same, and I can do that by definition of congruence. Step 3, angle 1 and 2 form a linear pair, and therefore I can draw the conclusion that they're supplementary, and that's definition of supplementary angle. I don't know if it's definition. Yeah, it's definition of supplementary angle, because it's actually definition of linear pair. Because says that if I have a linear pair, they have to be supplementary, or they have to add up to 180 degrees and be adjacent, right? So that's number 4. Now if we look at from 4 to 5, if we look at number 5, and that's definition of supplementary angle. Because from supplementary, I can draw that conclusion. And now if you go back and borrow step 2, angle 2 and angle 3, they are of the same measure. So from 5 to 6, I have angle 1, I keep that, but angle 2, I replace that with number 3. So that's a substitution. And then 180 still comes down, right? Or a transitive property. Either way you do it. In my case, I find substitution a little bit easier. So now angle 1 and angle 3 adds up to 180. And by definition of supplementary angle, they are supplementary. So you just made a proof there. Okay. Let's look at number 3. Number 3, first step is given. I haven't even read the problem yet. So let's go back and read the problem. Angle 1 and angle 2 form a right angle. So I have to mark it. And measure of angle 1 and angle 3 adds up to 90. Okay, so angle 1 is here. Angle 3 is here. So they add up to 90 degrees. And I have to prove that angle 2 and angle 3 are congruent. So I'm given 2 conditions. First one is in step 3, and then the second one, angle 1 and angle 3 adds up to 90. That's in step 3. So first one in step 1, I think I said. Sorry. All right, let's go back to step 1. Angle 1 and angle 2 form a right angle. Step 2, they are complementary, and that's by definition of, if I have a right angle, then these 2 angles adds up to 90 degrees to a complement. They're complementary angles. If I have a right angle, from right angle to complements, that is my complement theorem. Right? And then step 3, angle measure of angle 1 and angle 3 is the sum of it is 90 degrees. That's given. Step 4, then they are complementary, and this is by definition of complementary angle. Right? So again, I just want to point out, from right angle, I drew the conclusion of complementary. That is complement theorem. If I already have the measurement, I draw the conclusion that they are complementary. That's by definition. Okay? The difference is right here. Those 2 languages, the language in there are different. So now, the final step between step 4 and step 5. Step 4 says that 1 and 3 are complementary, and therefore angle 2 and angle 3 are congruent. And why is that? This is because this is by congruent complements theorem. Oops, sorry. Congruent complement theorem, which states that if this is the one that sounds like the transitive property, because it says that, I'm trying to mark it down, let's see, it states that if angle 1 and angle 2 are complementary, so that's step 2, right? And then in step 4 we says if angle 1 and angle 2 are complementary by step 2. And then in step 4 we prove that angle 1 is also complementary to angle 3. So it almost works like a substitution or a transitive property. Then we can draw the conclusion that angle 2 and angle 3 are congruent, and this is by congruent complement theorem, because that's what that theorem states. Okay, I hope I didn't confuse you. So in other words, congruent complements theorem and congruent supplements theorem work exactly like the transitive property. Let's see what else is behind here. I think I'm gonna let you guys finish 4, 5, 6, either at home or in class, depends on what homework you're assigned to. And let's see if I can. I wonder if I should do number 6 with you. Let me do number 6 with you, and then we can finish this here, because there is another one. Maybe I'll just make a separate video. Okay, so let's finish number 6. Number 6 says angle 1 and angle 2 are complementary, so which means that they add up to 90 degrees. Angle 3 and angle 4 are complementary, okay? And we have to prove that angle 1 and angle 4, we're trying to prove angle 1 and angle 4 are congruent here. So this is the part we don't know yet. But also, did you notice that it's not given? But on the graph, 2 and 3 are vertical angles. So I'm sure we're going to use that. Vertical angles are congruent, right? So let's mark out what we have been given. 1 and 2 are complementary. 3 and 4 are complementary. And therefore, 1 and 2 adds up to 90. And 3 and 4 adds up to 90 in step 3 and 4. And that's definition of complementary angles. And like we said earlier, 2 and 3 are vertical angles, and by vertical angle theorem, they are complementary. And therefore they are, if they're complementary, they're congruent. Sorry about that. If they're congruent, their angle measures are exactly the same, and that's by definition of congruence. Right? This works, definition of congruence works on angle measures and as well as segment measures, right? So number 7, notice from here, step 3 and 4 to number 7, and it takes a transitive property or substitution. Either one works. And also notice right here from 7 to 8, the difference is here. And if we borrowed 6, 2 and 3, angle 2 and 3 are of the same measure, so they're replaceable. So I simply did a substitution right there. And from there on, I can do an algebraic subtraction property, which is totally legal. I just subtracted the angle measure of 3, which is just a number, right? And now I have angle measure 1 and angle measure of 4, of angle 4 being the same, they equal each other. Therefore, by definition of congruence, they are congruent to each other. Okay? So that's number 6. I think 7, 8, 9 requires you to fill in the blanks on both sides, but they're fairly similar problems. And if you have questions, feel free to approach your teachers. Thank you, guys. Again, spend some time, take it slow, do a couple of a day. If you want additional practices, come to us and ask for help. Thank you. I'll see you in class.